Assalamualaikum warahmatullahi wabarakatuh, and good day to my panel Dr. Mohamad Syafiq bin Mispan and Dr. Haslinah binti Muhammad Nasir. My name is Mohamad Aiman bin Abdul from 4BEZ section 1/2. Today, I'm going to present my bachelor degree project 2 entitled with Development of Epileptic Seizure Detection based on EEG signal analysis using MATLAB. Okay, firstly on project description. This project is basically developing algorithm for EEG epilepsy recognition system by using feed-forward neural network as artificial neural network (ANN). This is to classify between healthy individual and epilepsy patient by evaluating their EEG data. This project also use raw dataset obtained from Department of Epilepsy University of Bonn, Germany. This raw dataset then used for training, validation and testing by using MATLAB Neural Network Toolbox. This project system invented to execute a process like human brain to recreate the way human brain think. For introduction for this project, firstly, epilepsy is one of the brain-related disorder affecting the entire brain system, and it is called by abnormal brain electrical activity, which is called as a seizure. Seizure can cause unconsciousness as a body shaking and many more of the brain-related issue. The 5 raw dataset which is contain 5 set of data labeled as A, B, C, D and E. One set of data contain 100 types of text file which consists of 4097 sample of EEG time series in ASCII code. Basically, the set A denoted as subset Z, which is healthy person during eye open. Set B denoted as subset O, which is healthy person during eye close. Set E denoted as subset N, which is epileptic patient, while set D denoted as subset F, which is epileptic zone before seizure, and lastly, set E denoted as subset S, which is in the region of seizure activity. And then the dataset decomposed using DWT. Next, the dataset doing training, validation and testing by using feed-forward neural network recognition system. After that, categorize the output data to which set it belong, either normal or epilepsy. Next objective of this project, firstly, to develop an EEG epilepsy recognition system using feed-forward neural network as artificial neural network (ANN). The recognition system is developed by using EEG data from University of Bonn. Secondly, to identify which sort of input data should be utilized to investigate epileptic seizure detection and obtain the optimum result for usage with neural network. 2 input data have been used, which are standard deviation and mean. This is to test the output result and compare which give the best overall accuracy. And lastly, to test real brainwave data obtained from EEG sensor by using artificial neural network (ANN) and execute using MATLAB. This is to test the real data with dataset that has been trained using University of Bonn dataset. Okay, methodology. Okay, from start you can see here there are 2 branches. From left branch, first raw data that obtained from University of Bonn is processed in MATLAB. Next, the data is imported and filtered by using bandpass filter. Then the signal is processed by using DWT method in the MATLAB. After completing the processed data, the input target is loaded to training, validation and testing by using feed-forward neural network. From training and validation, the data is able to classify by using A and N parameter. Then, if there is no error detecting during the process need to configure the coding script and repeat back at the beginning of import data into MATLAB. But if there is no error detected during the process, the test data is applied for the output, and the simple GUI will process to execute editor MATLAB file. At the right branch, mining EEG sensor is used to detect and read real data by using mining sensor. Next, Arduino is connected to computer, while Bluetooth module connected to Arduino. Then, data is read and retrieved by using Parallax Data Acquisition or PLX DAQ version 2.11. Then, If there is an error detecting during the process, the sensor need to configure back at the sensor and connection. If there is no error detecting during the process, the data will import to MATLAB for signal processing, for signal pre-processing, and testing the data using feed-forward neural network. Hence, the data is able to classify by looking at its parameter. Then the data able to test for its output. Okay, next, let's proceed for project result and analysis. In this project result and analysis, feed-forward neural network method is used to obtain the confusion metric. On the confusion metric plot, the row represent output class and the column correspond to target class. The green diagonal self correspond to observation that correctly classify, while the red diagonal self correspond to the incorrectly classified observation. Both the number of observation and the percentage of the total number of observation are shown in figure. The row at the bottom of the plot shows the percentage of all examples belonging to each class that are correctly and incorrectly classified. Next, before obtaining the highest accuracy data and pick the best result, the neural network hidden number is changing from 10 to 20. Hence, the best overall accuracy by using standard deviation and feed-forward method are at the hidden number of 17 with overall accuracy of 80.8%, training 80.6%, validation 76%, and testing 86.7%. For the input data of mean by using feed-forward neural network, same procedure is repeated by changing neuron 10 to 20. The best overall accuracy is obtained at neuron 12, which overall accuracy is 72.6%, training 74.3%, validation 70.7%, and testing 66.7%. To conclude for this both confusion metric, input data of standard deviation by using feed-forward neural network recognition system accuracy is highest compared to input data mean. Next, still on the result and analysis on this project, the process flow for feed-forward neural network training data and graph shown. From left, the input data X obtained from completing filtering, DWT, and standard deviation. Then the data will be in 8x500 metric arranged in Excel, and for target T, the 5x500 metric is used because the dataset contains 5 sets of EEG data. After that, the process use feed-forward neural network method as artificial neural network and train the data by changing the number of hidden neuron. Hidden neuron toolbox is used to plot receiver operating characteristic or ROC. Then from neural network toolbox, the confusion metric plot to obtain overall accuracy. Next, the overall summary for different number of hidden neuron changes in feed-forward method, able to plot in graph. The graph shown 4 types of data which are training, validation, testing, and overall accuracy. To conclude that overall data shows result percentage from 65% to 85%. Next, novelty and inventiveness. Firstly, myelin sensor and MATLAB can be used to detect epileptic. Secondly, MATLAB scripts are run using a simple graphical user interface GUI. Just press the button, MATLAB file will be executed. Next, the conclusion for this project. Firstly, the development EEG epilepsy recognition system using feed-forward neural network as artificial neural network able to develop successfully. Secondly, the input data of standard deviation and mean had been compared to obtain the optimum result. Based on this, standard deviation gives the best overall accuracy. Lastly, the real data obtained from sensor able to test and classify whether the data is obtained from set A, which is normal condition for eye open, or set B, which is normal condition for eye closed. From the test result from normal individual, we can conclude that this system able to implement to epileptic data. Next, for project features, these project advantages can help to examine the neuronal disturbance that happen in the brain because of epilepsy. Plus, huge data of EEG record can be optimized and analyze each EEG signal at different frequency subband and classify it using artificial neural network, which is much easy to implement. Since the dataset is complex and plain, which require analysis algorithm for accurate measurement, this project provides valuable diagnosis information which can support medical researchers such as doctors, researchers to studies and treating potential epilepsy patients. Input X, which is 8500 metric, is inserted to MATLAB. Input data X is obtaining after raw data university board has complete process of filtering, DWT, and standard deviation. Then for target T, input is inserted in 5 times 500 matrix. Then number of hidden layer in feed-forward network is changed to 15 neuron. Next, MATLAB is run and neural network toolbox is pop up. The data is trained and conclusion matrix plot. The data need to train so many times in order to get best overall result accuracy due to initial condition and sampling. This is hardware used in this project. First, Arduino is connected to USB and USB connected to computer. Then Arduino will turn on. After that, the EEG mini sensor is on and wear to the forehead. And after connected, the coding from Arduino IDE is uploaded into Arduino. The serial monitor is open to check the reading of sensor. The bulb is changed to 57600 according to the coding. As we can see here, from serial monitor we can see that the result is obtained from the min link. The serial monitor shows the X subband wave he retrieved from sensor. Next, PLX DIQ version 2.11 is open and in PLX DIQ interface pop up. After that, press connected button and make sure it is in correct port and baud rate. The data received process is in X subbandwidth. Each subbandwidth, which is delta, theta, low alpha, high alpha, low beta, high beta, low gamma, and high gamma. This is to show that the data is transferred into PLX DIQ. Next, to test the sensor data. The X subband is separated and each subband is find its standard deviation. Hence, the output obtained is 8 times 1 metric for X. For target T, 2 times 8 metric is used. Next, to test the 8 column of input X, the number of columns is changed from 8 until 1 to see whether the data is belonging in which category. There are two categories, which are category 1 and category 2. Category 1 is from 1 to 4, while category 2 is 5 to 8. As you can see here, if the number is changed from 8 to 5, the test indices show that the set is shown in category set 2, while the column is changed from 4 to 1. Test indices show that the data is in category dataset 1. Hence, to conclude from the test shows that the real data from sensor after testing give dataset A and B, or 1 or 2. This dataset is categorized as the normal individual dataset. Hence, this system can be applied in epilepsy dataset. Next, here is the simple graphical user interface GUI. There are 3 buttons, which is standard deviation, mean, and real-time training. So, when we push the button, it will execute the MATLAB editor file. Here is the result of confusion matrix of real-time training. Okay, that's all from me. Thank you.